Okay, Docker introduction. So we are going to learn what Docker is and why you want to use Docker. And we'll see some Docker ecosystems out there, and we'll just compare virtual machines versus containers. And then we are going to take a look at Docker architecture, what makes up Docker system. What is and why Docker? So Docker, if you actually go to Docker website, you see this message: build, ship, and run any app anywhere. So by any app, we are talking about all kinds of application. It could be Java application, it could be database server application, it could be app server, it could be Redis based some application, it could be Python, Ruby on Rails, you name it. Any application in the world can be packaged as a Docker image, and it should be able to run on any platform. So that's what it means by anywhere. Okay, so it really solves the problem of actually build once and you can run anywhere. Okay, yeah, I mean, solve the problem. You're gonna actually see the matrix hell problem. So we're gonna just move on to the next slide. Okay, so this is what I was actually talking about. Docker is actually some kind of container. You can think of it as some kind of container that contains everything that is needed to run that application on any platform. Okay, so a particular application could actually have some web application. It might actually use some kind of database. It might include some front end. It might actually have some queue. It might actually use some kind of database. Whatever things that are needed is self-contained in a Docker image, and that Docker image could be run on any platform. It could be development VM. It could be QA server. It could be some kind of customer data center. It could be run on public cloud, or it could be production cluster, or it could be somebody's laptop. Okay? It really doesn't matter. So this is basically why you want to use Docker. Without using Docker, basically suppose we have, let's say, 6 things that you need to actually include in your application, and then you have different platform that you have to actually deploy this application. You have to actually configure each of this individually without using Docker. So in this case, we are talking about 6 times 7, so we have to actually deal with a 42 combination of installation of components and configuration. Whenever things change, then whole combination again is gonna be a hell. Right? So Docker basically eliminates this matrix from hell situation that we typically have experienced without using Docker. Okay. Okay, so if you actually see the other, a little bit more descriptive explanation of why you want to use Docker in the website, this is what you are going to actually see. Universal packaging. So once you package your Docker as an image, that could be run on any platform, any situation. Complete developer toolkit. So it's very, very easy to actually use Docker. Right? And it comes with very simple set of the developer tools, usually in the form of command line tools. Built-in container orchestration. It does handle orchestration of what is called the containers, and it also actually handles what is called the clustering solution that is typically needed in production environment. Security by default. So we're going to actually cover a security aspect later on in the future sessions. So of course, whenever you are downloading some image from, some website and running it on your platform, you want to make sure that image is really secure, right? Okay. App-centric networking. So basically, you can actually construct various forms of networks using Docker, and basically it handles production level the environment. And extensible architecture. Okay. All right, so let's move on. Docker ecosystem. Yeah, so Docker was introduced in 2013, I believe, and it has been adopted in incredible speed because it really solved the real problems out there. Okay? So basically everybody is actually using Docker. Docker ecosystem. So it has a lot of actually ecosystem, the participants and partners and communities and developers, service providers, operating systems, configuration management, big data, service discovery, orchestration, system integrators, official repositories, development tools. Everybody's on Docker ecosystem, and that's a good thing. It is in fact a mainstream technology right now. Everybody is actually adopting it. Okay, comparison between virtual machines versus containers. So you probably have seen this comparison. So virtual machines was one of the solutions people used to use before Docker's emergence, and virtual machine is solving some problems. Basically, you could actually have some kind of virtual machine created, and that should be able to run on some kind of a remote server, things like that. So the difference between the two is that if you see on the bottom, there is some server and host operating system, and virtual machine hypervisor technology, and then you basically have a complete image that contains guest OS and binaries and libraries and and that application. So there is no sharing between these virtual machines in terms of libraries and guest operating systems. So the size of virtual machine is huge. On the other hand, container basically is actually sharing. Containers are sharing the operating system as well as binaries and libraries. The size of the containers is very, very slim. Okay, so container is actually providing virtual the image basically, and it could be in fact created and stopped a lot easier than virtual machines. I mean, as you can actually see in a few minutes, creation of containers and the destroying of containers is so simple compared to virtual machines. Okay, so Docker architecture. So basically, this is the picture that we're going to actually use several times moving forward. So there are three, let's say, players in Docker architecture. On the left, we have a Docker client, and in the middle, we have a Docker host. And Docker host is running what is called a Docker daemon. And basically, you can think of Docker daemon as a Docker machine. And Docker daemon actually has a list of images that are downloaded from registry. So registry is internet repository where people posted their images. Okay, by the way, images basically, so let me actually explain each of these components in a bit more detail. Images is basically, you can think of a file, set of files, and configuration of a particular application. Okay? So these images are in fact posted by people to the Docker Hub. So in fact, there are thousands of images out there in the Docker Hub and Docker Registry. Those are the same thing. Okay? And then containers. So containers are running instances of Docker image. Okay? So containers run actual applications. So basically, once this images is pulled from Docker Hub into this Docker host, and then you should be able to execute that image, and each of those instances of the image will be run in a container. Okay, so a single image could be run in multiple container instances. So container instance is the one that is actually running the application instance. Okay, so in the Docker host, you have a set of containers, and each of those containers is representing particular application instance. And these images in the Docker host are basically pulled from this Docker Hub. And then you have a client. Client should be able to access these containers. Okay. All right, so we are going to actually take a look at this slide one more time, and we'll move on. So Docker daemon, this is a background service running on the host that manages building and running and distributing Docker containers. So basically, this Docker daemon is responsible for managing these containers. Okay, starting and stopping and removing and all those things. And the client should be able to actually manage those containers and images using the client command. Okay, so Docker client is command line tools, basically set of command line tools that allow the user to interact with the Docker daemon, meaning Docker the host. And Docker Hub is basically a repository and registry of Docker images. Does that make sense? All right, so we're gonna actually kind of play around all these things in the lab moving forward. Okay, so that is the end of very quick introduction